Hello everybody. In this episode I will show you how my code works to manipulate a binary search tree. So in my code you can add a node, you can search for a node, and you can delete a node. Okay? So you can download my code. You'll find a link in the descriptions below, but let me explain how my program works, and I explain also a little bit how I explain my code also. Okay, just a little bit. Okay, so let's run the program to show how my program works. So that's my program. So my tree now, your tree is null. So to add a node, press 1. If I want to add one node, I press 1. To search for a node, I press 2. So if it exists or not. And to delete a node, I press 3. And to exit process, I press 0. Okay. So for example, let's see this. Let's use one tree here. Let's enter this tree here. Okay, so that's my program here. Excuse me. So I want to enter. So to add a node, press 1. So I press 1. So enter node key. So to add this node, so I enter 25. Excuse me, 25. So your tree now is 25. I have just one node in my tree, 25. So let's enter all these nodes. So I press 1 to add. So 12, 1. I add 36. So that's my tree. In each time I add a node, my tree is great. Okay, so let's add 10, 22, 30, 40. We have 5. We have 12, 28, 38, 48. So that's my tree now. So the left is the minimum. Okay, the leftmost is the minimum. So if the node is less than the parent, I go to left. If it's great, I go to right. Okay, because that's when I display here 25, 20, 10, 5, and then 12, and then 22, and then 36, and then I print 30, 25, and then 40, 38, and 48. Okay, that's my tree. Okay, let's now search for a node. Okay, to search a node, I press 2. So let's press 2. So let's search for an existable node. For example, we don't have 55. 55 here it say that no node not exists. There is no node with this key. Okay, let's for example search for 25, which is the root of our tree. So node exists because it exists. Let's search for example for 5. So 5 exists, node exists. That's 5 here. Let's search for 48 for example. Node exists. So let's now delete a node. So let's try to delete a node with two children. For example, 36, we have two children, this and this. So let's delete. So to delete a node, press 3. So 3, enter node key to delete. So I want to delete this 36. So when I, so it explains how the program, what the program do, because this 36 has two children. You know that we search for the successor. We can search for predecessor, but in my case I want to search for the successor, because that is, it say that the successor of 36, I want to delete this 36. So the successor of 36 is 38. So that's the successor, because I go step to right and then I go to left. That's the successor. I assume that you know how to find the successor of a node with two children. Okay, so that's the successor 38, and then what we do, we link 38 left, so which is the successor, with 36 left. So we make this, the left of this node equal this. Okay, I assume that you know how to delete a node with two children manually, because that's the program we manipulate. Okay, so we link the left of the successor with the successor of the node we wanted to delete. So we make the left here, the program it say that we link the left of 38 with the left of 36, which is 30, and then we link 25, which is 25 is the parent of the node we want to delete. So the 25 right, which is this, the right of this 25 with 36 right, with the right of this. So we link this right with this, and before that we link the left of 38 with 30. Okay, and then we deallocate 36, so we delete 36. That's our tree now. Okay, 36 is deleted, was deleted. Okay, so that's the case if we delete a node with two children. Let's, for example, just delete for example 30. 30 is simple, just because it has just one node. Okay, so let's delete. So to choose option, because to delete we press 3. Let's delete 30. So 30 is very simple to delete. We don't explain as this in this step. If we have two children, we explain here in the program. Because it's simple, we just delete it. Okay, in the program just makes the left of the parent of 30 equal the left of 30. Okay, let's delete the root now. Root has two children. Okay, 25 is the root here. The first is the root. Okay, here in the program the first is the root. Let's try to delete it. We delete 25, so enter the key we wanted to delete 25. So here it say that the successor of 25 is 28. Okay, is 28, because this is deleted now, but this it is 28. Even after we delete this, it stay, because it stay, the successor here is 28, and we link 25 left with 25 left, and then we tag 40. We tag 40 because 36 is deleted here in this program. Okay, we tag 40 as root because 40 is a new root now because we delete this root here. Okay, and we deallocate 25. That's a very very good program. Okay, so if we want to delete, for example, 5 is a leaf. It has not any children, nor left nor right. So let's try to, so even after you delete something, you can, every time you can add other nodes. For example, if I want to add, always I press 1 as option here. So let's, for example, enter this number. So that's a new node created here. Okay, every time I can add or delete. Of course you can't, because those are keys. You can't, when we add the new key, it must be not available, already available. Okay, because that's a key. For example, if I want to add, so I have I already have 28. So if I want to enter 28, it says that node already exists because that's the keys. If you have another information, you can just add another information in the node because those are just the keys here. Okay, the keys, it's like identifier. You don't have to make two nodes with the same key. Okay, so so let's try to delete the whole tree. So always press 3 to delete 40. If I want to delete, for example, 88, it says that node does not exist because 88 it's not exist. So we can delete an available node. That's logic. Let's delete 48. I want to delete the whole tree. So if you want me to make any program for you, you can contact me. Okay, you will find my informations in the descriptions also. Okay, let's delete 5, 10. Let's delete 22. So this is our tree always. Okay, so I delete 20. Let's delete, we have only one node here, which is the root. So our tree now is null. Okay, it's empty. So you can enter in each time you wanted to enter new nodes. Okay, so that's how my program works. Okay, so let's explain a little bit the program, the code. Okay, so this is our code. So here we have this function, the manual. Here we say to add node press 1, to search node press 2, to delete node press 3, to exit. So if I want to exit, I press 0. Okay, so that's the option. So the program ends. Okay, so to exit press 2, and here I say choose option, and I enter the option, and I return this function, return the option. Okay, unsigned int. Okay, so here we check. So that's, I declare an option. I use this loop here, do while. So and each time I call the function manual to print the manual of the program. Okay, so here if I choose 1, if option is equal 1, so here I add the node. Okay, so at first I enter the key of this new node, and at first I search if this node exists by the function find node. I will explain it later. Okay, and I send the root and the key because this is a recursive function. Okay, so if this node is null, that's mean that I don't have this key. Okay, so I can add this node. If if the n found this here, this function return a node, that means that this function this node is already exists. The node with this key here is already exists. I just say this message, node already exists. If it's null, so this node is not exists, so I call the function add node. So let's go to add node. Here I create a node, I make this key equal this key, I send with this function, I enter in the main function, and I make left equal null and the right of null of this node also is equal null. So if root is null, that's mean if my tree is empty, I make root is equal this new node. And if my tree is not null, I call the function with this new created node and with the root. And this is a recursive function. So if parent key is greater than this new key, because that means that I want to enter it in the left, I go to the left. Okay, so if parent left is equal null, I link the left of the parent with this new node here. Okay, else I call the function with the parent left. And I assume that you know how the binary search tree works. Okay, because you want to know how to binary search a tree to understand the code. Okay, else, so if the key of this new node is great, so I go to the right. Here I will go to the left, and here we go to the right. So if parent right is equal new node, so if it's equal null, so I will link this new node with the right of this. But if it's not null, we go to the right and we send the new node. That's a recursive function. Okay, so that's how we add. Option 2, we search. Okay, we search if a node exists. So here we enter the key, and we search with this function find node. Okay, and so if this node is equal null, that means this node is not exists, and if it's not null, we say that node exists. So let's see the function find node. Find node, yes, find node. So if n is equal null, we return null. If this node we search for it's null, we return null. And if this node key is equal this key we search for, excuse me, we must first see the structure. The structure of any node, we have a key and the right and the left, and initially the root of this node is equal null. Okay, so if this node key is equal the key we search for, we return n. And if key is greater than this key, we call the same function. That's a recursive with the left, because that's if the key of this node is greater than the key of the node we search for. So because that we go to the left, else here we go to the right. That's the same thing. Okay, but here we go to the right and here we go to the left. If the key of the node we search for is less than the key of the current node, we go to the left, and here if the key is greater than the key of the node we search for, we go to the right. Okay, so that's it for the search. For the delete, So we enter the key of the node we wanted to delete, and here we search. So we use the function find to search of this if this node with this key exists. So if it exists, if it doesn't exist, we say that node does not exist, because we can't delete a node when this node is not exist. That's logic. Else, so that here in this case, so here we search for the parent of this node, because we need the node, the parent of this node in the deletion process. Okay. So let's see the function parent. The parent so the parent is simple. If n is equal root, we return null, because in this case that's so if this node we search for is equal the root has not parent, so because that we return null. If this function return null, that means that this node we search its parent is root. Okay. Else, if parent left, so if parent left, because if for example here this, so this, so we say if for example if we want to search for 12, so if 10 here, if its left is equal this or its right is equal this, that's mean that this is the parent of this, because there is two cases. 10 is 12, the right is 12, because each node has two children, because that we say if left is equal this node or the parent right is equal this node, we return parent. Else, so we search normally. Okay, if this parent key is greater than this node key, we call the same function, which is a recursive function here with a parent left. Else, so here if node key is greater than parent key, we call the same function, but here we say we search with the right. Okay, that's it for the parent, because we need the parent to delete. Okay, and then we delete a node and we send this pointer of the parent to delete, and we send delete to the node to delete. Okay, so that's the last function. So here, so that's delete node. We send the parent of this node we wanted to delete and the node. For example, here in this function, if we want to delete this, for example, if we want to delete this, we send to this function delete, we send the parent and the node we wanted to delete. Okay. So if n left equal null and n right equal null, that means that n is leaf. This n we wanted to delete. So here we check if parent equal null. That means if this node to be deleted is a root, I make root equal null and I free this node. So else, that means that this node is not a root and it is leaf. It's a leaf, but it's not root. Here in this case, I make parent left. If parent left is equal null, I make parent left equal null. I free n. So and if parent right is equal this node we wanted to delete, I make parent right equal null and I free null this n here. Okay. So in this case, if n left is not null and n right is equal is null, that means that if this node has just one node, one children, and we have just the right children. For example, in this case, for example, this has has just one children which is left. That's what mean this case here. Okay, and we check if it is a root also. So we make root equal n left, because that means that if I want to delete this node which has just the left children, but it is root, this node, I make root equal n left, and then I free this n. Else, so that means that this is not the root, I make parent left. If parent left equal n, I make parent left equal n left, and I free n. So, and else, if parent right is equal null, this n, I wanted to delete parent right equal n left. Okay. So here also I want to free n. Okay. Here I want to free n. I forget. Okay. So here in this case, if n left is equal null, so that's mean in this case this node has only the right children. Okay, for example, only the right children. It has not left children, but it has one right children. So if this node is a root, so I check root. In this case, if this is a root, I make this root is equal n right, and I free this n. So else, that means that this is not the root. In this case, so I check if this parent left is equal null. In this case, I make parent left is equal n right, and I free this n. In the other case, if this parent right is equal n now, in this case I make parent right is equal n right. And here also I forget. Here also I wanted to free this n. Always when I delete, I free the node. Okay, so that's the most important case. So if the node, this node has the left and the right children, in this case was the first thing, we wanted to search for the successor of this node. Here I declare this pointer as a successor, and because here in this case we have two children, so to check the successor of a node with two children, so we must go to the right. Here we don't need to check, because we know that this node has a right to children. Okay, and then while successor left is different than null, I go to, so I make this successor is equal the successor left. So here in this line here, when I stop, when this loop is stopped, we check. So here we have the successor. Okay, so here equal the we have the successor now. So here we always print the successor of the n key is equal the key of the successor, because we print how the program work in this case. So if the node to be deleted is a root, so in this case I make the successor left is equal this node we wanted to delete left, and here we print, we link the successor key left with the n key left. I will make the root is equal n right, So and then we deallocate this n here. Okay, so else so that's mean if this node, that's here, else mean that if this node is not the root. So that's simple. I make successor left equal n left. So here just to print what we do here. And so if parent right is equal n, so because there is two choices, because we say that if we have this node, for example, if we say that this is the parent of this node, we wanted to know if this is the right child of this or it's right, because that we make this condition here. So if parent right is equal null, so parent right is equal n right, and here in this case we make parent left is equal n right. Okay, and we deallocate this n here. Here we just explain. Okay, see that's out here. So that's it. If you want to download my code, you will find the link in the descriptions below. And if you want me to help you in your program, so you don't hesitate to contact me. You will find my contacts in the description section below. And see you soon.